find the Fourier series of the function f of x is equal to 0 and x, and limit for 0 is x is greater than minus pi and less than 0, and limit for f of x is equal to x is greater than 0 and less than pi. This is the given function, and we will find the Fourier series of this function. So what will be the requirement for finding the Fourier series? So first we will find a naught coefficient of Fourier series an, bn, and last f of x the Fourier series. So come to solution. As we know that Fourier series is f of x is equal to a naught divided by 2 plus summation n star from 1 up to infinity a n cos nx plus summation n star from 1 up to infinity b n sin nx. This is my equation A. Now we find a naught first. So we know the formula for a naught. I already proved it before in lecture. First, a naught is equal to 1 over 5 integral 0 to 2 pi f of x into dx, where 0 to 2 pi and here minus pi to pi. So integral minus pi to pi is equal to integral 0 to 2 pi. This is equal. Okay, now the function is divided into two parts. One is 0 and another is x. So the limit for 0 is minus pi to 0, and then for limit for x is 0 to pi. So we will divide this limit in this way. A naught is equal to 1 over pi integral minus pi to 0, the function is 0, into dx plus 1 over pi, and this limit integral 0 to 2 integral 0 to pi is the function is x. So we will write x into dx. Okay, now a naught is equal to integral of this function is 0 plus 1 over pi, integration of this x is x square divided by 2, and limit is 0 to pi. Now we will apply the limits. So a naught is equal to 1 over pi. We will put an x limit and x, so pi square divided by 2 minus 0. So pi is cancelled with pi square, so we will get a next step. A naught is equal to pi divided by 2. So now this is my equation. First, now we will find an. An is equal to 1 over pi integral minus pi to pi f of x and 2 cos nx into dx. So n is equal to 1 over pi, the limit integral minus pi to 0, and this limit the function is 0 cos nx into dx is plus 1 over pi integral 0 to pi, and this limit the function is x, and this cos nx is and the formula, and to dx. Now n is equal to 1 over pi, this integration is also 0, so we will find the integration of this function. So x into cos nx into dx. This is my first function and this is my second function. We will solve this integral by integration by parts formula. So we know the formula for integration by parts. So an is equal to 1 over pi, first function is x, so first function integral of second function is cos nx to dx, and limit is 0 to pi minus whole integral limit 0 to pi derivative of first function. This is first function, so dx by dx, integral of second function cos nx into dx and whole dx. N is equal to 1 over pi x, integration of cos nx is sin nx divided by n, limit is 0 to pi minus the derivative of x with respect to x is 1, and integration of this cos nx into dx is sin nx divided by n into dx. Now n is equal to 1 over n pi. Apply the limits. Okay, so we will first apply the limit n x. So phi sin n pi minus 0 minus 1 over n pi minus cos nx divided by n. Integration of sin nx. Here is sin nx divided by n. So the integration of sin nx is minus cos nx divided by n. So a sin n pi is equal to 0. N is equal to 1 over n pi. So this is sin n pi is 0. 0 minus 0 plus this minus multiplied by this minus. So plus n multiplied by n square into pi. And cos n pi, when we apply the limit, minus cos 0. As we know that cos n pi is equal to minus 1 power n also. So n is equal to, this term is 0 plus 1 over n square pi, and we will put cos n pi is equal to minus 1 over n pi, minus 1 over n. So minus 1 over n minus cos 0 is equal to 1. N is equal to 1 over n square pi into minus 1 for n minus 1 r. N is equal to 1 over n square pi. We will replace also, we will write also cos n pi minus 1. Now this is my equation 2. Now we will find Bn. So Bn is equal to 1 over pi integral minus pi to pi f of x sin nx into dx. So Bn is equal to 1 over pi, and this limit minus pi to 0. We split this limit into two parts, minus pi to 0 and 0 to pi. So minus pi to 0, the function is 0 and 2 sin nx into dx, plus 1 over pi, and this limit 0 to pi, the function is x, so sin nx into dx. The integration of this is 0 plus 1 over pi. This is again by integration by parts formula. This is my first function, this is my second function. So we will solve this integral by integration by parts formula. Okay, so integration by parts formula, Bn is equal to 1 over pi, x is my first function, integral of second function minus whole integral 0 to pi derivative of first function dx by dx, integral of second function into dx. Bn is equal to minus 1 over pi x. Integration of sin nx into dx is minus cos nx divided by n, limit 0 to pi, minus whole integral 0 to pi. Integration of sin nx is minus cos nx divided by n into dx. Bn is equal to minus 1 divided by n pi cos nx, limit 0 to pi, plus this minus is multiplied by this minus, and this is also 1 over pi is also multiplied with this. So minus multiplied by minus, plus 1 over n pi, and again the derivative of cos nx is sin nx divided by n. So Bn is equal to minus 1 divided by n pi. Apply the limits. Here we put an x, so phi cos n pi minus 0 plus 1 over n square, this n is multiplied with this, so n square pi, and also apply limit here, sin n pi minus sin 0. Bn is equal to minus 1 over n pi cos n pi plus 1 over n square pi. Sin n pi is also 0 and sin 0 is also 0. So Bn is equal to minus 1 over n cos n pi plus 0. We will also write Bn is equal to minus cos n pi divided by n, r. Bn is equal to minus of cos n pi is equal to minus 1 power n divided by n. This is my equation 3. Now putting values in equation A from 1, 2 and 3. So we will get the Fourier series of the given function. So now we will put the values of from 1, 2 and 3 in equation A. Equation A implies that f of x is equal to the value of n naught is pi divided by 2, so pi divided by 4 plus summation n star from up to infinity 1 over n square pi cos n pi minus 1 n2 cos nx plus summation n star from 1 up to infinity. The value of Bn is minus cos n pi divided by n n2 sin nx. F of x is equal to pi by 4 plus 1 over pi is common from this whole, so we will get from this whole, so we will get 1 over, and we will expand this summation. So 1 over pi is common, so here 1 over n square is left. So when we put n is equal to 1, so 1 over 1 square cos pi minus 1 into cos x. When we put n is equal to 2, so 1 over 2 square cos 2 pi minus 1 into cos 2x up to infinity, plus, and this function we will also write, we will expand this summation. So when n is equal to 1, so minus cos pi divided by 1 into sin x. When we put n is equal to 2, so minus cos 2 pi divided by 2 into sin 2x. When n is equal to 3, so minus cos 3 pi divided by 3 into sin 3x up to infinity. F of x is equal to pi divided by 4 plus 1 over pi. Here we multiply or not multiply. Here we see that cos pi is equal to minus 1. Cos pi is equal to minus 1. So when we put minus 1, so minus 1 is minus 2. So cos x into cos x divided by 1 square plus cos 2 pi is equal to 1. So 1 minus 1 is equal to 0. So whole term is 0 up to infinity. Okay. And this term plus cos pi is minus 1, so minus 1 multiplied by minus, so 1 is cancelled with 1, to sin nx divided by 1 minus cos 2 pi is equal to 1, so minus 1 over 2 and 2 sin 2x up to infinity. F of x is equal to pi divided by 4 plus minus 2 cos x divided by this pi is multiplied with this, so pi 1 square plus up to infinity plus sin nx divided by 1 minus sin 2x divided by 2. The third term is sin plus sin 3x divided by 3, and the fourth term is minus sin 4x divided by 4. So this is the required Fourier series for the given function. Now we will discuss even function and odd function. So what is even function? A function is said to be even only if we replace x by its negative, still we get the same function. Or I will discuss it here. Or if we replace x by minus x and give him back the same function is called even function. For example, here f of x is equal to x square. This is one function. If we replace x by minus x and we will get the same function back, so this is the even function. So see, f of x is equal to x square. When we put x by minus and we replace x by minus x, so f of minus x is equal to minus x whole square. So f of minus x is equal to x square. So f of minus x is equal to f of x. So we will get the same function back when we replace x by minus x. So this is even function. Now see another example, f of x is equal to cos x. If we replace x by minus x here and here, f of minus x is equal to cos minus x. And I already told you cosine is a even function, so this minus is absorbed inside again cos. So f of x minus x is equal to cos x, so f of minus x is equal to f of x. So this is again give him the same function back, and we replace x by minus x. So the graph of even function is symmetric on the y-axis. Example for even function are x square, x power 4, x power 6 are cosine function. So let's we see that it is true or not. So this is a cosine function, uh, and we know that cos 0 is equal to 1. So this is the point. Cos minus pi by 2 is minus 1. Cos minus 3 by 2 is also minus 1. Cos minus pi by 2 is equal to 0, and cos minus pi is equal to minus 1, and cos minus 3 pi by 2 is 0, and cos pi by 2 is also 0, and cos pi is equal to minus 1 this point, and cos 3 pi by 2 is equal to 0 like that. So now you will see this function, the cosine function, is even. Why? This is symmetry on the y-axis. This is the point. They are left side and right side are the mirror image of each other. So if we take this, so this is the mirror image of this side. Okay, so this is the cosine function is the even function. Now we will prove that the area under the even function from minus pi to pi is double. I already told you that minus pi to pi, integral minus pi to pi is equal to 2 times integral 0 to pi. So we will prove that the area under the even function from minus pi to pi is double the area from 0 to pi. So as we know that, come to the proof, as we know, integral minus pi to pi f of x into dx is equal to, we will write in this way, we will split into two integral from minus pi to 0 f of x into dx. This is 1 plus integral 0 to pi f of x into dx. This is the second integral. This is my equation A. We will prove that this is the double. So I is equal to, this is integral I is equal to minus pi to 0 f of x into dx. I replace x by minus x here, x by minus x. So x by minus x. So we will get as f of minus x into minus x is equal to f of x, because it is even function. This is part even function we will prove. So f of minus x is equal to f of x. We will discuss in the definition. I is equal to integral minus pi to 0 f of x into dx. This is equal to this f of x, but this minus is take out from the integral. Now I is equal to the second, when we change the limit, so integral 0 to 5 f of x into dx, this minus is observed, is eliminated when we change the limit, when we interchange the limit. Okay, as an even function, minus pi is equal to 5 also. So put equation 1 and equation a. This is equation 1. When we put an equation a, we will get equation a implies that integral minus pi to 5 f of x into dx is equal to, we will put equation 1 and equation a. So integral 0 to 5 f of x into dx, replace the value of this by this, so plus integral 0 to 5 f of x into dx. So this is the same, so we will add them. So we will get integral minus pi to 5 f of x into dx is equal to 2 times integral 0 to 5 f of x into dx. Hence proof. This is double of the integral from 0 to 5 f of x. You will see integral from minus pi to pi f of x into dx is equal to double of the function integral from 0 to 5. So hence it is proved. Now we will discuss odd function. Even function is symmetric on the y-axis. Okay, and odd function, now you see what is odd function. If we replace x by minus x and we get the negative of the given function, is called odd function. An even function, when we replace x by minus x and we get the same function back, so we will call even function. And here it is the opposite. If we replace x by minus x and we get negative of the given function, so it is called odd function. Are those functions which satisfy the following condition are called odd function. F of minus x is equal to negative of the given function. Let for example f of x is equal to minus x. Replace x by minus x. So when we replace x by minus x here and here, so f of minus x is equal to, this is the given function, f of x is equal to x, and this is the and this is, so when we put f of x is, if we replace x by f by minus x, so we will get f of minus x is equal to minus x. So f of minus x is equal to negative of the given function, because this x is equal to f of x, so we will replace in this x f of x, and this negative sign is already here. So this is the negative of the given function, and we replace. For example, another example, f of x is equal to x cube. When we replace x by minus x, so we will get f of minus x is equal to minus x cube, and this is equal to minus x cube. So given function f of x is equal to x cube, and then this is the negative of the given function. This is the given function f of x, but here sign is negative, so this is the negative of the given function. Now we will see that f of x is equal to sin x. When we replace x by minus x, so we will get negative of the given function, because sine is odd function. I already told you in the third lecture that sine is odd function and cosine is even function. So the graph of note, so the graph of sine x is symmetric on the origin. So the graph of the sine function or odd function or odd function is symmetric on the origin. So the graph of every odd function is symmetric on the origin. Let you see in this graph that this is the sine graph, sine function graph. So this is symmetric on the origin. This is the mirror image of the this type, this side. So this is symmetric on the origin. Let's I will solve one problem on this so you will clear now. Draw the graph of the function f of x is equal to x at this point minus 3 and 2 3. This is the points and this is the given function, and we will draw the graph of this function. So f of x, when x is equal to minus 3, f of x is equal to minus 3 when x is equal to minus 2. So x is equal to minus 2 when x is equal to minus 1, f of x is equal to minus 1 when x is equal to 0, f of x is equal to 0 when x is equal to 1, f of x is equal to f of 1 is equal to 1 when x is equal to 2. So f of x is equal to 2 when x is equal to 3, f of x is equal to 3. This is the limit, this is the points. So minus 3, minus 2, minus 1, 0, 1, 2, 3. This is x axis and this is y axis. Minus 1, minus 2, minus 3, 0, 1, minus 1, minus 2, minus 3. So we will take the points here. If x is equal to, this is on my x-axis and this is my y-axis. When x is equal to 0, f of x is equal to 0, this is point. When x is equal to 1, f of x is equal to minus 1. F of x is equal to 1 when x is equal to 2, f of x is equal to 2 when x is equal to 3, f of x is equal to 3. When x is equal to minus 1, so f of x is equal to minus 1 when x is equal to minus 2, f of x is equal to minus 2 when x is equal to minus 3, f of x is equal to minus 3. So this is the graph straight line. So this is the mirror image of, so this is the mirror image of this. So this is a straight line. This is symmetric about the origin. It is symmetric about the origin. It is an odd function. So there it is, an odd function. Odd function is always symmetric on the origin. Okay. So I hope you will learn something and from me in this lecture. So we will continue this lecture and solve some questions on odd and even function in the coming lecture 5. Inshallah, wait for lecture 5 and subscribe my channel and share it with your friend. Thanks a lot. Goodbye.